All right, I figured you folks might need a little bit of help. I don't think I'm going to get through all of these. And if you hear somebody chewing Cheez-Its or talking, I have an Evelyn with me. Okay, so might as well go back through and make the model. And I'm just going to go through a couple of these the entire way. So our job here is to find the point on the curve, y equals x squared, that's closest to the point 3, 0. So what we're going to do is we're going to choose a generic point xy. And, obviously up here at, let's say, 3, 9, that's not the closest point to 3, 0. We're looking for this distance. And, well, that distance is just the hypotenuse of a right triangle. So we can use Pythagorean theorem, the distance formula, whatever you call it. Now, the other thing is xy isn't the best way to write that. We always want to use one variable if possible, so we're going to call that point x and x squared. Probably should have had a bigger diagram, but oh well. So what that means is, this side length down here, that's 3 minus x, and this side length over here, that is 0 minus x squared. I don't really like those. I think I'm going to switch them around. Anyways, so the distance is the square root of, instead of 3 minus x, I'm going to do x minus 3 squared plus y, or x squared minus 0 squared. Now, it turns out, just because of the way square roots work, that instead of doing the minimum of that distance, I can actually just do the minimum of, basically the same expression without the square root, and we're going to find the same critical value, but it wouldn't necessarily or have the same output. But anyways, our job is to find the point. We're going to get the same x value out of either of these equations, so we might as well use the easier one. Now, the domain here is all real numbers. So why is that? Well, we could find the distance between 3, 0 and any x coordinate on that graph. Although we know it's going to be something larger than 0, just visually, obviously. Okay, so anyways, I think maybe I'll multiply everything out. And that's going to be x squared minus 6x plus 9. And then plus x to the 4th. So f prime of x is 2x minus 6 plus 4x cubed. And we're going to let f prime equal to 0 so we can find some critical values. So 0 is equal to 2x minus 6 plus 4x cubed. Now, it's not terribly obvious that what the critical value is going to be. And, factoring by grouping doesn't appear to work. This is definitely not a sum or difference of cubes, like all our techniques aren't there. But I suppose what I notice is that's a 2, plus 4 is 6, minus 6 could be 0. Just, coincidentally, we can figure out, it looks like x equals 1 is going to make this true. So, that's pretty obvious. 2 times 1 is 2, minus 6 is negative 4, plus 4 is 0. But we might have another critical value. So what I'm going to do is 4x cubed plus 0x squared plus 2x minus 6. I'm going to do some synthetic division. 0 plus 4 is 4. 1 times 4 is 4. 2 plus 4 is 6. 1 times 6 is 6. Negative 6 plus 6 is 0. So now we can see what's left over. Well, here's our x minus 1 factor. That's basically what we divided out. And we're left with 4x squared plus 4x plus 6. And I don't know about you, but I can pretty easily see that if we were to do the quadratic formula on that 4x squared plus 4x minus 6, underneath the square root, we'd have 4 squared minus 4 times 6. And we don't even need to write the rest. That's going to give us some non-real roots. So we can just kind of skip over that. So anyways, we just get x equals 1 is the only critical value. I'm going to make a sign chart. Domain is all real numbers. There's x equals 1. These are x's. And what do we call this? So we're going to say sine of f prime. And let's see. Well, let's see. If I use a number greater than 1 like 10, that's going to be 10 minus 1 is positive. 4 times 10 squared is positive. 4 times 10 is positive. Everything's positive. F increases from 1 to infinity. I assume we're going to get something negative over here. Why don't we just substitute in 0? Let's see, 0 minus 1 is negative. 4 times 0 plus 0 plus 6. So that ends up being, f prime is negative when x equals 0, so all values less than 0. All right, so what do we do now? We need to justify. So f of x is continuous. At x equals 1, f prime changes from negative to positive. So f of x has a local minimum. And the distance is minimized when x equals 1. The closest point to 3, 0 is 1, and then how do we get the other one? 1 squared. Okay. I think that's good. Hopefully that helped. I think I'm only going to do one more. We need to make a Costco run. And what should it be? Open top box is pretty straightforward. You should be able to find that online. 4 is the same as number 1. Okay, I think I'm just going to do the second one. Hopefully that'll help. Who the heck knows? Okay, so most of the periods we kind of did this together in class. The manager of an 80-unit apartment complex is trying to decide what rent to charge. Experience has shown that at a rent of $200, boy, that seems cheap, all the units will be full. So currently, $200 and 80 units means the apartment manager is bringing in, what is that, $16,000 a month. Yeah, that seems pretty good. On average, one additional unit will remain vacant for each $20 increase in rent. Find the rent to charge so as to maximize revenue. So that kind of seems like if we're going to do $220 per apartment, then we will have 79 apartments full, which means I think that's actually a little bit more money. And maybe $240 means 78 apartments will be rented. And so I think that's good enough to write our equation. So the total amount of revenue, we'll figure out what our unknown is. Well, that first one is just 200 plus 20 some variable number of times. As in the first one, we added 20 0 times, and then 1 time and 2 times, and so on down the line. And the other one is 80 minus, 1 times whatever that x is. Now, x is kind of two things. So x is, I don't want to say the number of $20 increases in rent. So that's one thing. X could also be the number of vacant apartments. Because notice that's actually true in both cases. But one of those the landlord, the manager, has control over and one he or she doesn't. So X should be the number of $20 increases in rent. And let's see. Everything's full, so that means we can't go less than 0. Okay? If we had a negative number, we could charge less than 200, but we're already renting out all 80 apartments, so we can't make more money because that would just be 80 times 180 or 80 times 160, and that's obviously less money overall. Okay. And then on the other end, maybe we should do equal to 0. On the other end, we could decrease the rent by $20 80 times, and eventually this side gets down to, well, 0 apartments are being rented, so we don't want to include that. And, well, I think that's a good domain. Okay, so let's not multiply everything out. Let's just do the product rule here. So r prime of x is going to be 200 plus 20x times negative 1 plus 80 minus x times 20. And I guess we're going to have to set that equal to 0, so we might as well multiply everything out. Negative 200 minus 20x plus 1600 minus 20x. So let's let r prime of x equal 0. And maybe rearrange at the same time. Oh, that's nice. This is actually going to be way easier than I thought. Okay, cool. So that's going to be 1,400 minus 40x. 40x equals 1,400. X equals 140 divided by 4. X equals, what is that? 70 over 2. X equals 35. Oh, those aren't arrows. Those are going to be bars. So we said 0, 35, 80, x. Sine of r prime of x. Okay, so let's go back and make sure we get the correct sign. So it seems like, I think I'm going to look right here. When x equals 1, that's going to be negative 200 minus 20 plus 1,600 minus 20. That's pretty obviously positive. And I guess if we use, is 50 big enough? I think 50 is big enough because r prime of 50, I'm doing this in my head, but I guess I'm writing it for you, is going to be negative 200. And then 20 times 50 is going to be 1,000 plus 1,600 minus another 1,000. That's clearly negative. Okay. I'm doing that in my head, but it's hard to follow. Okay. So that means we definitely found a maximum. And I think we're kind of good to go on justification. So r of x, the revenue function, is continuous, but not everywhere, on 0 to 80. R prime of x changes from positive to negative when x equals 35. So the revenue is maximized. Maybe I'll put that in parentheses. R of x has a local maximum when x equals 35. I think we were supposed to find the most rent, right? Find the rent to charge. The rent we should charge. Oh, it's not we. I always put myself in the situation. The manager should charge is, well, remember it was starting off with 200. Oh, dude, he's charging a lot. And then 35 is the number of $20 increases in rent. So that's just going to be 200 plus 20 times 35. I guess I'm just going to type write dollars. So, 20 times 35, what is that, 700? We should do $900 overall, but don't forget, we don't have to worry about addition, subtraction, multiplication, division. I hope that helps.